inequalities using addition or subtraction. Okay? An inequality is less than, greater than, less than or equal to, greater than or equal to. Okay? So we're going to start solving inequalities and we're going to start graphing inequalities. And I'm going to show you 2 ways that you have to know how to graph them. Yay. Okay. An inequality is a statement formed by placing an inequality symbol between 2 expressions, such as y plus 5 is less than or equal to negative 6. Okay? So instead of having an equal sign, I'm plugging in an inequality sign.
I'm finishing a test.
Yeah. Okay. The solution of an inequality is the set of all real numbers that produce true statements when substituted in for that variable. Okay? So it's just like when you're solving an equation, my solutions can be infinite solutions, my solutions can be no solution, or I can have a solution that is just one answer, correct?
Yes.
Okay. Inequalities have the same type of things that happen. My solutions can go from 5 on up, there could be no solution, or there could be infinite solutions where it covers the whole number line system. Okay? We're going to talk about how we graph those. That is what an inequality is. So an inequality is when I have an equation, basically, okay, an inequality symbol placed between 2 expressions. Okay. With that being said, we then come to this chart where they have inequalities. We're going to put it in words. We're going to put it in a graph. You're going to have to be able to do all 3 interchangeably. And you're excited. How would you read this inequality right there? X
is less than 3.
X is less than 3. So when I put it into words, I say X is less than 3. Okay? When I graph this, what does that mean?
Oh, it's like a line thing?
It is, well,
It's like a line.
yes. Yes.
Don't you start it from the 3
Uh-huh.
and move it to, is it the right or
To
left?
the, if I say X is less than 3,
Okay,
that
to
means,
the left. Sorry, to the
yes.
left.
So here's my graph, right? Here's 0, 1, 2, 3, -1, -2, -3, because I like to see some numbers. If X is less than 3, that means any number on this side fulfills that statement, correct?
Yeah.
Do I have a open or a closed dot? Open. Okay, so I have an open circle, and then I'm just boom, 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 boom. Okay, that is one way to graph it. I need to show you a second way to graph this. The second way is using brackets or parentheses instead of open and closed dots. Okay? You have to know both ways because on state testing they're going to show you both ways and you have to know how to read it both ways. If you wanted to graph this, okay, with a bracket or a parenthesis, here's the rule. If it says less than, or if it says greater than, you use a parenthesis because what that parenthesis is telling me is it doesn't include that number. If it says less than or greater, less than or equal to, or greater than or equal to, you use a bracket because it says I am using that number as well. Okay? So on this one, you have an open circle or you have a parenthesis. Okay? On your homework tonight, when it asks you to graph them, I want you to graph both ways for me. You're doing 2 graphs. I know, you can complain all you want. But you're doing 2 graphs because I need to know that you know open or closed circle, and I need to know that you know parenthesis or bracket. Okay? How do I read this one right here?
Y is greater than 2.
Y is greater than 2. Okay? Y is greater than 2. So I'm going to do another line here, right? 0, -1, -2, -3, 1, 2, 3. Where do I put my open or closed circle?
At 2.
At the 2. Okay. Is it open or closed?
Open.
And how does this statement become true? Do I shade to the right of that circle or to the left of that circle?
To the right.
To the right, because if I plug in a 3, is 3 greater than 2?
Yes.
Boom.
We learned last Gotcha. Whenever the
Yeah.
less than or equal to the sign is pointed to the left.
Correct. You are correct. Now, if I was doing this in the other notation way, would I use a bracket or a parenthesis?
What'd you say?
I said if I do it in notation form, that's what brackets and parentheses are called. Do I use a parenthesis? And I still shade the same way. Okay. How do you read somebody besides Carter or Kate or Katie? How do you read this?
Z is equal to or less than.
Z is less than or equal to. And if I graph that, okay, if I graph that, how do I graph that with closed or open circles, and where do I go and start, and what do I do?
Close.
Close.
Close, and then you move to the left.
Okay, so I'm going to close it, and then I'm moving to the
Left.
left because it's less than or equal to. Now, when I graph that in notation form, I'm using a bracket. Brackets are drawn like that, okay? And you're shading like this.
So we use bracket when it's equal to or less than.
Yes, because what that's saying is I'm including that number. 4 is an option to work there. If I have a parenthesis, I'm not including the number that I'm going around, okay? How do I read this statement right there? Jacob, how do you read the last one?
N is greater than or equal to 2.
Good. N is greater than or equal to 2. N is greater than or equal to 2. And I go to graph that. Okay, how do I graph that? Open or close, Jacob?
Close.
Close circle. And which way is it going to face?
Right.
To the right. So I go to the right. So then if I put it in the other form, in notation form, I again am using a bracket and I'm going to the right. Okay? So you have to know how to graph both ways. Okay.
We have to know.
You have to know how to graph both ways because on state testing they're going to show you it both ways. So I need you to get used to it, okay? That's why I'm trying to prepare you so that you can do well on the ACT and stuff like that. And when you get into Algebra 2, they drop this whole method completely and never do it again. They only use brackets and parentheses because when you write your answer, you're going to write it with brackets or parentheses. If you write it like 3, 4, you're going to use a bracket or a parenthesis to do that. So we're kind of just easing you into the future. Okay, the freezing point of water is 0 degrees Celsius. At temperatures at or below freezing point, water is solid, it's ice. Okay? Write an inequality that gives the temperatures at which water is solid. Then graph the inequality. So we've got to write the inequality, then we have to graph it. Okay, so where does water freeze in this?
0 degrees Celsius.
0 degrees Celsius, okay? So my water is freezing at 0 degrees Celsius, okay? Which means what? When else would it be frozen then?
Less than 0 degrees
Okay,
Celsius.
good. Less than 0 degrees Celsius. So you said less than, so how do I create that inequality? What does that look like?
Is it like a variable less than or equal to
Yes.
0 degrees
Good.
Celsius?
So you're going to just pick a variable, and you're going to say like, in this case we're working with temperatures, okay? So the temperature is less than or equal to 0 degrees Celsius. There's my inequality, okay? Don't make it harder than it is. You can put an X there, you can put a Z there, you can put whatever variable you want, I don't care. I just chose T because we're dealing with temperatures and my mind goes to that, okay? So the temperature is less than or equal to 0 degrees Celsius. Now, how do I graph that both of my ways. I'm going to count by tens because when you're dealing with degrees. How do I graph that both ways? Do I have open or closed circle?
Closed.
Closed. And which way am I going to
Left.
end up?
Left.
Okay. So I have a closed circle, and I'm going this way. Which means if I write it in notation form, what am I using down here? Brackets. Brackets. Okay. Brackets, because it has less than or equal to. If it has an equal to sign, I make a bracket. Okay. Next on the list, just like 4 more things. Equivalent inequalities. What does the word equivalent mean?
Equal to.
Equal to. So an equivalent inequality is an inequality that has the same solution. Okay? So if they tell you to see if these inequalities are equivalent, you have to see if they have the same solution. Okay? Or you have to check by plugging things back in. You know how we've been plugging things into our equations and checking? We can do the same with inequalities. Okay? So they might want us to solve an inequality. Let's say they say solve this. And it is m plus 5 is greater than or equal to 10. How would I solve that if it said equals? What would you do? You would what?
Subtract 5.
You would subtract 5. So what do you think we're going to do when it says greater than or equal to? Subtract 5. Nothing changes. I literally solve the same way I've been solving. So I subtract 5 from both sides, yes? And I get m is greater than or equal to
5.
5. M is greater than or equal to 5. Now, I can check this, okay? I can check my solution.
So is that the answer?
Well, that is the answer. M is greater than or equal to 5.
Do we
But
have to graph it?
you still have to graph it, okay? So let's graph it. If we graph this, I have 0, 1, 2, 3, 4, 5, 6, 7, okay? -1, -2. Okay, so I go to m is greater than or equal to 5. What do I put?
Closed dot and
Closed
it
dot.
goes to the right.
A closed dot, and it goes to the right.
And you
Or
use
I could have
brackets.
used a
Bracket.
bracket. Okay, or I could use a bracket. I just put them all on one there. You can do that on your. Yes. If you want to do that on your homework, go for it. Show me the closed dot and show me the bracket together. That's fine.
Would that have one solution, or would you do you want to represent the bracket solution too?
No, that's fine. You can do it that way. You can grab it on the same thing. Save some time. Okay, now to check this answer, this is where it's a little different. Okay, because I have nothing to plug back in, right? I'm going to choose a number that is either 5 or greater than 5. So I'm going to just choose 6 and plug it into this equation. Okay, so this is how you check. I'm going to say 6 plus 5 is greater than or equal to 10. So 11 is greater than or equal to 10. Is that true?
Yes.
Yes. So I have graphed this the right way. Okay? That's how you can check your solutions. So if it tells you to check a solution, that's what I'm looking for. You could have plugged in 8. You could have plugged in 10. You could have plugged in anything past 5 here. So you can check your answer different than your neighbor does. Does that make sense? Okay, so don't stress if you guys don't check it the same way.
Please excuse this
Okay,
interruption.
let's try this
At
one.
this time, I need 7th grade students. Q is inquiry. To W as in wait. Come
Solve.
to the front lobby at this
Graph, check. Okay, solve, graph, and check. -10 is greater than x minus 12. What do I do there? How do I solve? Not you, Carter. Someone else. How do I solve, Jason?
You
Are you Jason?
no.
Jason, how do I solve? What do I need to start to solve that? Emma, what do I do? Add 12. Add 12 to both sides. What's -10 plus 12?
2.
2. So 2 is greater than x. Okay, so I'm graphing my inequality. Where does my dot go? Is it open, close? What's happening?
2 open. Positive 2 open. It goes
Okay.
to right.
And I can also put through here a
Parentheses.
parenthesis, and it's going to the
Right.
Right. Sorry, left.
Right.
2 is greater than x. If 2 is greater than x, that means x is less than 2.
To the left. To the left. I'm so confused.
That's because this is written in a different format than this. Yes? My variable's first, my number is next.
Oh.
Correct? Here, my number is first, my variable is second. If it's written this way, I cannot just point and go that way.
The opposite.
You have to go opposite because it says 2 is greater than x. So is 3, if I say 2 is greater than 3, is that a true statement? No. So I have to shade to the left on this one. So pay attention to that if you solve your inequality and it's not written variable first, then number. If it's written number first, then variable, that's why we're going to check our solutions, okay? So now I can plug in a number. I'm going to plug in 0. Is 2 greater than 0?
Yes.
Yes. So I shaded right. Okay? Be careful on that because that becomes a little bit tricky. Okay. One last word problem, and I'm just reading it, and we're going to plug it in, okay? And I'll show you a little table that goes with it. Event time. Okay? Event
Being good.
time. Guys, focus. Okay, your event and your time. So you have 3 activities: swimming, biking, and running. Okay? Swim, bike, and we run. We swim for 17 minutes. We bike for 45. And we run, we have no idea. Okay? And it says, you are competing in a triathlon, swimming, biking, running. Okay? A sports competition with 3 events. Last year you finished the triathlon in 85 minutes. So my finish time last year equals 85 minutes. Okay, that's pretty good. The table shows your times for this year's first 2 events. What possible time can you post in the running event and still beat last year's time? Create an inequality.
Ooh!
Okay, Jacob, what?
17 plus 5 is
17 plus what?
5.
5.
45.
45.
45 is
17 plus 45 is
greater than
Less than.
what?
It's less than.
I want to beat the time of 85 minutes. So I want to be
So
less than 85 minutes. Okay. So it's less than 85. Now,
Yeah.
I have a problem with this equation. What am I missing?
X.
Run.
Yeah, I'm missing the run. So
Run
the variable. So we're going to just put a
plus X.
x here. Okay. So I add 17 and 45. What do you get when you add 17 and 45?
Wait, you?
Yeah, you get 62.
I am terrible at math.
Now, how do I solve from there?
You subtract 62.
to each from each side.
Good. And I get x is less than
23.
23. Now, what do you have to do from there?
Make a
Make a graph.
Right.
Yes, make a graph. Okay, so I make a graph. X is less than 23. So we're going to go 10, 20, 30, negative 10, negative 20, negative 30. Okay, open or close?
Open.
Open. Parenthesis or bracket?
Parentheses.
Parenthesis. Open parenthesis. We're going to pretend 23 is right here. And which way am I shading?
To the left.
To the left, to the left. Okay. Boom, 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 boom. Boom. You've solved word problems using inequalities. Let's do this.
But
$2 million bucks.
You were in the video.
Maybe if I can get the video to stop. My computer doesn't let me in half the time.
Me too.
Thank you. Oh, that's good.
You just keep
Yes.
Bye. Wait, why was he here?
Because he was getting money for me.
Oh, is he
Because
doing?
he was trying to
I have
correct you
homework
because
for
you were
you.
saying try
Oh,
not
good.
to. You should have been saying try fast.